So, just when you think you cannot be blown away any more than you already are at the American Astronomical Society in Pasadena, the conference, you get to sit in on a talk by a George Ellery Hale Prize winner and lecture by Dr. Wang. The talk was titled, "The Sun as a Laboratory for Astrophysical Magnetic Fields." Dr. Wang's entire talk hit completely different, and it was so next level that I am back here just to tell you all about it because it is something that is so incredibly unique than what anyone is saying right now. Dr. Wang was also incredibly generous and a wonderful person to talk to after the talk. He said not even solar physicists understand subjects that he was talking about. So he gave me kind of a behind the scenes of everything that he had discussed during his presentation so that I could then share it with all of you. So there's a very big problem with astrophysics in concerns with the sun and studying the sun and understanding the sun. Coronal holes are dark regions within the sun with open magnetic field line to allow for fast solar winds to escape. But here is where the problem begins. The sun rotates at different speeds. The equator rotates faster, while the poles rotate slower. Because of this, you'd expect the coronal holes to shift and get twisted at different rates, distorted and shredded over time. But observations going back to 1973 showed something very bizarre on the sun. Coronal holes remain remarkably rigid, meaning they don't get twisted, they don't get distorted, and they don't shred, as what we would expect. So, okay, before Dr. Wang came along, scientists just explained this away. They just said, oh, coronal holes are rooted deep in the sun, and that's why they stay rigid. But Dr. Wang had a completely different approach and a completely different model that he presented at the conference. He instead focuses on boundaries. His main idea is that there is continual magnetic reconnection. At the boundary of a coronal hole, closed field lines open and open field lines close. Magnetic flux is constantly exchanged. So the individual lines are changing, but the overall coronal hole shape remains remarkably same. The analogy that kind of brought it all together and blew me away was the image of a river. The water molecules inside the river are constantly changing, yet the river's shape itself remains pretty much the same. So why do we care, and why is this so elegant, and why did Dr. Wang just stop me in my tracks and made me think, well, wait a second. If we're saying that these coronal holes don't necessarily change their shape over time, what does that actually mean about the sun? Dr. Wang proposes his model that the hole stays fixed because the boundary is continually reorganizing itself through magnetic reconnection. In other words, rigidity emerges from continual change, which is almost hard to wrap your mind around, but it does make complete sense. So this is why I think it's so incredibly important to come to these conferences and to talk to scientists like Dr. Wang and get their ideas behind these new models. The sun is literally out there maintaining itself through chaos. This is my second day at the American Astronomical Society conference in Pasadena. I could not be more thrilled by my very last talk that I got to see today. I hope you really enjoyed the topics and, well, follow along because tomorrow we're going to do it all over again.